will show you my research proposal, a new alternative for offshore wind turbine foundation, a Wahoo-Rough foundation. We are all probably familiar with wind energy, but the fact is that the installation of wind turbines has been increasing exponentially. That requires larger capacity and larger turbines to fulfill the requirements. Also, offshore wind energy is becoming more popular because offshore winds are steadier and faster. The components of a wind turbine are the rotor, the turbine, the tower, and the foundation. There are different types of foundation, and that depends on the water depth on site. But the two most popular ones are monopiles and the gravity-based foundations. Any type of foundation is subjected to normal and axial loads and bending moments. The gravity-based foundations rely on its own weight to provide structural stability against these loads. And as we can see in Figure 8, it requires larger dimensions to fulfill these requirements. The objective of wind energy is to produce less greenhouse gas emissions compared to fossil fuels, but the truth is that building the system itself produces emissions. That's why we have to assess the sustainability of the wind turbines. There are three components: environmental, economic, and social, and we are going to focus on the first two. The life cycle of a wind turbine has 4 phases. However, most of the emissions are produced during the manufacturing. As can be seen in Figure 9, almost 50% are due to the foundation. However, as the turbine operates, the ratio between emissions and kilowatt of energy produced reduces. The foundation can also represent between 20 and 40% of the total cost of the system. Our proposal consists of interconnected concrete beams or a Wahoo-Rough foundation. This foundation requires less volume of steel and concrete, therefore reducing the emissions produced in manufacturing, but it also has to fulfill the structural requirements of the design. The variables of our research will analyze the performance under static and cyclic loading to determine the structural behavior of the system, the interaction between the foundation and the turbine tower, and between the soil and the structure to determine settlement and scour, all through numerical modeling and prototype testing. The environmental impact will be assessed through an LCA, and the cost reduction through a cost analysis and cash flow. These are examples of the results of numerical modeling and prototype testing in which a scour was detected. Thank you for your attention.